Welcome back, our dear learners, and thanks for watching. Please inform your colleagues to continue downloading the app. The app is QuestLift on Google Play to get access to this information here. We are talking analysis, gradient function of a curve. Gradient function of a curve. Previously, we've discovered that we have discovered that dy, we have discovered that dy dx is equal to the limit as delta x tends to 0 of f of x plus delta x minus f of x all over delta x. And I've said that our dy dx is called the gradient function of the curve y is equal to fx, or it can be a derivative or a derived function. Then also dy dx can be written as f prime of x or y prime to indicate that we have differentiated once or first time. We have differentiated once or first time, or we can call it the first derivative. Examples. One, we're saying find the gradient functions of the following curves. Find the gradient functions of the following curves. We have Roman 1, y is equal to x squared. Roman 2, we have y is equal to x cubed. Roman 3, we have y is f of x is equal to ax to the power 4. Roman 4, we have y is equal to 5x squared minus 3. Y is equal to 5x squared minus 3x minus 3x minus 3x. Let's look at the solution. Roman 1. We have y is equal to x squared. Now, from y plus delta y, this one is equal to x plus a slight change in x, then you square. When there is some slight change in y, there is a corresponding change in x. So we have y plus delta y is equal to, we expand this one here, this is x squared plus 2x, then delta x, then plus delta x squared. Okay, so if we want delta y is going to be x squared plus 2x delta x plus delta x everything squared, then minus y. So delta y is equal to x squared plus 2x delta x, 2x delta x plus delta x squared minus the value of y is x squared. So you consider that one and that one are cancelling out. So if they cancel out, if those two cancel out, we'll remain with, what do we remain with? We'll remain with delta y as equal to 2x delta x, then plus delta x squared. So since we need delta y delta x, divide through by delta x, divide through by delta x. So if you divide through by delta x, you have delta y over delta x is equal to, now if I divide here, I'll remain with 2x plus delta x. Then as delta x approximates 0, we have delta y over delta x, this one approximating dy dx. So dy dx is equal to, now if I substitute, this one has approximated to a full derivative and you'll end up with a 2x. Alternatively, if I don't use that format, alternatively, I can let y to be f of x. So that means my f of x is equal to x squared. So if my f of x is equal to x squared, that means my f of x plus delta x, this one is equal to x plus delta x squared. Okay? So we do have something like the one we are going to look at. We have, therefore, from dy dx, which is equal to the limit as delta x tends to 0 of f of x plus delta x minus f of x, then all over delta x, meaning we have dy dx as the limit as delta x tends to 0 of, now my f of x plus delta x is this one here, it is x plus delta x squared, then minus x squared all over delta x. So I do have dy dx as equal to, we have the limit as delta x tends to 0 of what is happening in that bracket there. When we expand, we have x squared plus 2x, then delta x, then plus delta x squared minus x squared all over delta x, all over delta x. So you consider this one and that one are cancelling out, and we have dy dx as the limit as delta x tends to 0 of, we have 2x delta x, then plus delta x squared over delta x. So if you divide all through by delta x, this one will cancel and one of the delta x's will reduce. You have the limit as delta x tends to 0 of 2x, then plus delta x. Okay, that one is dy dx. So our dy dx finally is, now as delta x tends to 0, this one will tend to 0, and what do you remain with? You remain with a 2x. You remain with a 2x. I'm going to pick out two more examples. I've looked at the first example using two methods. Why? To ensure that people get accustomed to the two, because they are easier to use. Now, let's look at example number 3. Example number 3 is y is equal to ax to the power 4. Ax to the power, no, it is f of x. It is f of x is equal to ax to the power 4. Now we have dy dx. This one is the limit as delta x tends to 0 of f of x plus delta x minus f of x over delta x over delta x. So my f of x is ax to the power 4. Then what is my f of x plus delta x going to be? My f of x plus delta x is going to be a, then we have x plus delta x, everything is to the power 4. We learned how to expand that from the Pascal's triangle. We learned that under algebra. So therefore, what is this one going to become? We can expand it at that level. We have a, everything into x power 4, everything into x power 4 plus 4x cubed delta x plus 6x squared delta x squared delta x squared. I think let me start it from here. My space is not enough. I have a into x power 4 plus 4x cubed delta x plus 6x squared delta x squared plus 4x delta x cubed, then plus delta x to the power 4. But everything is under that bracket. Everything is under that bracket. Therefore, what do I have? I have something like this. I have something like this. My dy dx, this one is the limit as delta x tends to 0 of, from there we have a x. I think this space is not enough. Let me try to widen the space. Let me try to widen my space here such that it is big enough. I have therefore dy dx as the limit as delta x tends to 0 of my f of x plus delta x is this one. I can have it as ax squared plus 4ax cubed delta x plus 6ax squared delta x, this is squared, plus 4ax delta x cubed plus a delta x to the power 4, then minus my f of x is a x to the power 4, then everything is over delta x. You close. So you can see that this one is cancelling out with that, and we have dy dx as the limit as delta x tends to 0 of, now from here we have 4ax cubed delta x plus 6ax cubed delta x squared, that is x squared delta x squared plus 4ax delta x cubed, then plus a plus 6a, it is a 6, it is just delta plus a delta x to the power 4. Now everything is over delta x. You close this, you close that. So if you divide through by delta x, if you divide through by this delta x, you can see here the delta x disappears, but there is one delta x which remains here. Here remain with delta x squared, here remain with delta x cubed. Therefore, your dy dx or f prime of x, I said those two mean the same thing, is equal to 4ax cubed, because from here, if you divide, you remain with delta x here, you remain with delta x squared here, you remain with delta x cubed there. So as delta x tends to 0, the whole of this goes to 0, the whole of this goes to 0, and that one also goes to 0. And what do you remain with? You remain with 4ax cubed. You remain with 4ax cubed. Therefore, when you differentiate ax to the power 4, you end up with 4ax cubed. You end up with 4ax cubed. We shall continue from there.